Welcome to section 9.1, and this is where you're going to start to identify quadratic functions. We've already been talking about linear functions. We've now been playing around with quadratic formulas, and those quadratic formulas look something like this. We'd have maybe y is equal to 2x squared plus 4x plus 1. And as of right now, we haven't seen too many that have the y equals part of it. We've been seeing a lot of this, the 2x squared plus 4x plus 1. And we've been forced to use FOIL, or we've been forced to factor these out for the last chapter. Now with this particular video, we're going to be, number one, identifying what is a quadratic function from tables, but then also we are going to, number two, graph them using tables or an equation. So let's get started. Here we go. What is exactly a quadratic function? Well, a quadratic function is something that can be written into this form. We have y is equal to ax squared plus bx plus c. If it can't be written like this, and that is where a, b, and c are real numbers, not imaginary, so you won't have the square root of a -1 for a. These need to be real numbers like 4, -2, and 16.5 or something like that. They need to be legitimate numbers. If they can be, or if you can have an equation written like this, then you have a quadratic function. And the way you can really see it is you're going to see this x squared in here, and you're not going to see funky variables or funky exponents added to your variables. Let's look at this particular table right here. This, I'm going to tell you, is a quadratic function. And let's look and see why this is a quadratic function. And we're just going to look at the table here. So if I go from 0 to 1, all I'm doing is adding 1. And we can see a pattern here. If I go from 1 to 2, we're adding 1. 2 to 3, adding 1. 3 to 4, adding 1. If I look at the bottom part, we're adding 1 here. We're adding 3, adding 5, adding 7, between the 1, the 1 and the 4, the 4 and the 9, and the 9 and the 6. Now, as of right now, we can't see that there's any real pattern except for that this is 1, 3, 5, and 7 at the bottom, and that's kind of like increasing everything by 2. So we're adding 2 here, adding 2, adding 2. So if we are looking at what's called the second differences within a table, so if not the first difference, but the second difference, if we can create a constant change in the second difference, then it is, or we can identify it as a quadratic formula. So there's two different ways to identify if something is a quadratic. Two ways. If you have a table, we need to look for the second differences. And if we have an equation, we need to be able to fit it back into that ax squared plus bx plus c format. So let's look at two problems here. We have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Your job is to figure out if it is a quadratic function. So is it a quadratic equation? So let's create ourselves a table. And your table can either be vertical or horizontal, it doesn't matter. But we're going to put x and y here, and that's all we're comparing. We're just comparing x's and y's. We have 5 points, so I made 5 points there, and now I'm going to fill in the blanks. So looking at this, if I were looking at simply the changes in the top, we have a +1. Here we have a +1. Here a +1. So you can see a constant change of 1 here. And if there is not a constant change of something, the change has to be constant there. If it's not constant there, then we won't be able to actually identify if this bottom half is anywhere near constant. We have a 4 to 1. That is a -3, subtracting 3. Right here we're subtracting 1, here we're adding 1, and here we are adding 3. So if we look at this, we subtracted 1, added 1, added 3. Now let's see if we have a constant second. So 3 to a -1, we have to add 2 there. 1 to, or negative 1 to positive 1, we're adding 2. 1 to 3, we're adding 2. There is our second change. That's our second difference. So this is a quadratic function. That's awesome. That's what we want. Now, our next problem that we have y is equal to x plus 2x squared. We need to see if this is a quadratic function, and we're going to use that equation formula. So if we notice on the equation, it said y is equal to ax squared plus bx plus c, where a, b, and c are all real numbers, and a real number could be 0 potentially, which is a good thing. And if I notice here, I have this y kind of off by itself. It's y is equal to everything else. And if I look at my current equation, we have y plus x. So it looks like I need to do a little algebra here. I need to subtract x from both sides. So if I do that, I have y on one side of my equation, and then I have 2x squared, and then subtracting my other x. So y is equal to 2x squared minus x. Now, if I look at this, it doesn't look quite like this original equation. I have this ax squared right here. And I have my bx, and I can always rewrite this as saying, instead of subtracting an x, I can write this as plus a negative x. So there's my bx. But I'm missing a c. Well, I just said before, a real number for c could easily be 0. And if that's the case, there's my c. It doesn't change my equation at all by adding 0 to the end of it. So yes, this as well is a quadratic function. That is a good thing. That helps us out. Now, sometimes you might not be able to turn it into this equation, or sometimes these second differences don't truly happen. And all you're doing is you're looking at the differences between each of the numbers, the original numbers here, and then these numbers here. You're looking for a difference, a second difference. So now let's go on and let's look at how to actually graph quadratic functions as well. This is a table that we have here, x and y, and what we need to do is fill it out. We need to fill it out so that way we can then graph. So if x was equal to negative 2, what could y equal? And in all reality, you can just pick arbitrary numbers for these. However, I would consider doing 5 numbers that are kind of in a row. And unless you see anything funky in your quadratic, pick them around the origin. So negative 2, negative 1, 1, 0, and 2. These are all numbers that are just along the origin. And if you notice, I'm picking numbers just that are on the x-axis because this is in the x column. So if x is equal to negative 2, and we put it into this equation, y is equal to 2 times a negative 2 squared. Negative 2 squared is equal to 4 times 2, we got 8. If I did the same thing with 1, I could find that out. So I'm just going to pause this video and actually get that in there, so stick with me. Alright, so it was a split second for you, but for me it was like 2 minutes. So we have 8, 2, 0, 2, and 8. So I filled out the table, and I did this all with this same equation, and I just changed my x value. And what I ended up with is a bunch of coordinate pairs. I essentially have my x, comma, y. Negative 2, comma, 8 is a point on this graph. So let's actually graph that. I can go to negative 2 on my x-axis, 1, 2, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8 over 2. There we go. That's one of our points. Our other point is 1, 2, or negative 1, 2. There we go. We have 0, 0, a 1, positive 2, and a 2, positive 8. So if I look at this, I actually start to see sort of a V shape. And if I were to actually expand this out a little bit, I could see it even more. And I'm not actually going to say it's a V shape. I'm going to turn this into a U shape. This is a U shape, and it's a U without a tail, so it's like this. If I were to actually check what a half is, or a negative a half, or a negative quarter, or something like that, I would find that I get closer and closer to the origin, but it doesn't quite turn into a point. It actually is a nice, smooth curve. So what's created is called a parabola. So if you have a quadratic equation, the resulting graph is called a parabola. So before, when we had y is equal to mx plus b type equations, we got linear equations, and now we are in and y is equal to ax squared plus bx plus c situation, and they create parabolas. So this parabola is the result of a quadratic equation. Let's try another problem. This is our new problem. We have our x's and we have y, and we actually don't have anything filled out in this table. Y is equal to negative x squared plus 2, and we actually need to create a table for this, so let's pick some random points. And like I said, let's pick them around the origin. Unless something is drastically different in our world, unless something looks really funky here, you should always pick points that are around the origin. It's just a fairly good idea to do. So pick some points around the origin. If x was equal to negative 2, let's stick that in there. We have y is equal to negative 2 squared plus 2. And you ask probably why. Well, why did you put 2 negatives? Well, x was negative, but then there's also, in our equation, there is a negative. So there's going to be a negative there. I'm just going to have that be there. So negative 2 squared plus 2. So let's actually do this math. Negative 2 squared is a positive 4. We still have that negative out in front, so we have a 2. Negative 4 plus 2 is equal to negative 2. So our answer for this equation is negative 2. I'm going to pause this and fill out the rest of the table, and we will continue on after that. Alright, once again, it was a lifetime on my world, but it was super quick with you. So here we go. Here we have all of our points. We essentially have coordinate pairs here. We have negative 2, comma, negative 2. And I'm actually going to put that in different colors. We have negative 1, comma, 1, 0, comma, 2, 1, comma, 1, and 2, comma, negative 2. So let's actually graph these now. Negative 2, 1, 2, over 2, down 2, so here is our point. We have negative 1, over 1, up 1, perfect, there is our point. We have 0, 2, so there is our point. 1, 1, oops, not there. We have 1, 1, over 1, up 1, there we go, there's our point, and then over 2, down 2, so there's our point. And we're just going to finish off our graph. And if you are feeling unstable with just locating 5 of these points, then you can always make your table bigger and locate 7 of the points and look for negative 3 and positive 3. Or negative 4, add that in and look for 9 points and a positive 4. You can do as many as you need to make this understandable for you. But that is how you graph an equation. And up above is how you identify quadratic equations, looking for that second difference or looking for equations that fit that y is equal to ax squared plus bx plus c. I hope this helps. Be sure to watch video number 2 for the next step of this section. Thank you very much.